Hello everyone, welcome back to Calculus BC. We're in lesson number 39 where we're talking about polar equations, and in this video we're going to continue talking about how to find area between two curves. In this video we're going to talk about the intersection of the two curves. So in the previous video, you guys can see at the bottom here, we talked about how to find the area between two curves, and we're not going to do the outer of one equation but the inner of the other. Well, in this video I'm going to talk about two examples where I'm going to find the intersection of these two curves. So I want to find the area of the intersection of these two curves right here. So first thing we got to do is we got to draw them. We got to look and see what it is and be able to draw what they are. So these are actually pretty easy functions to draw because they're just circles. So in F here, I'm going to go ahead and do 2 sine of theta. So 2 sine of theta is just going to be a circle that's going to go up to 2 units. 1, 2. And then I'm going to go ahead in this mustard color for g of x, do 2 cosine, and 2 cosine of theta is exactly the same thing as 2 sine, except for now we're going to be on the x-axis. And so this tiny little region right here, is what I want to do. So like in the previous video, we actually have to set them equal to each other because we got to find our intersection points. So we're going to go ahead and do 2 sine of theta is equal to 2 cosine of theta, which means that sine of theta is equal to cosine of theta. So we know that that's true at pi over 4. I mean, there's other places too, but you guys can see that the intersection point clearly right here is going to be pi over 4. So what we do to find the area of an intersection is we have to trace it. We have to trace it along here. So we want to know what the purple is right here. So we're going to use the 2 sine to find this little region. And then we're going to use the 2 cosine of theta to find this region. So let's actually do that. The first thing is, it's really important for this one, so you want to be very careful with this problem, and I'm going to go ahead and keep it in the same color here. So for the area of the purple, we're going to start here, and we're going to move our way up to pi over 4. So remember, guys, that from this starts at 0. Remember, for sine of theta, the function starts at 0 and goes up to pi over 4. Which most of you guys will, that's obvious. But yes, it is. But you want to be very careful about that. So we're going to do the sine squared theta, and we're still going to just do quantity squared d theta. That's going to give us the half of it's going to be from here to here, and it's going to cut it straight down to this intersection point. And then what we need to do is find the second part of this. So we want to go from here to here. Now guys, this is not 0 to pi over 4. Because 0 is right here. Remember that for 2 cosine of theta, this is 2. So we're actually going to go here to pi over 4. So we're going to start this at pi over 4. And remember that if you think about circles, that this would actually do 2 rotations, right? So if I were to actually trace this over the interval from 0 to 2 pi, we would do 1, we would do 2. Our period's actually pi. So if I were to go all the way back around here, this is pi. So this would be pi over 2. Now the easiest way to do this, if you're still completely confused about what I just said, is you could plug in. You can plug in, okay, what angle for cosine is going to make this 0? So if I plug in cosine of pi over 2, I'm going to get 0 here. So that's probably the easiest way, the most direct way for me to tell you that. But the reason I showed you guys this example is that these are not the same intersection points. Well, they intersect the same spot, but these are not the same bounds. And so then we're going to go ahead and just do 2 cosine of theta, quantity squared, d theta. And so this is the setup that you're going to use to solve this problem. All right, so let's go ahead and do another problem that was very similar to this one. And actually, it's a continuation on the problem that we did in the previous video. So in example number 8, we said find the area of the region outside of r equals 3 plus 2 sine of theta and inside r equals 2. And so we found the region that was right here. We found the intersection points. Well, now we want to change it up slightly and say, now let's find the area enclosed by the common interior of these two graphs. Instead of finding the area right here, I'm going to find the area of what's here. So I'm going to find all of this area that you guys can see in this particular example. So the common interior of the both. So what's inside all of them. So what we're going to do is this. We're going to do the long way and we're going to do the short way. So the long way is, what we're going to do is we're going to start at 0. We always start at 0. And we are going to be tracing this shaded region. So you guys can see that there's some red, then we get to green, and then we get a tiny little bit of red right here before we come back. So the first thing we're going to do to find this area is we're going to do 1/2, and then we're going to go from 0 to, now we're right here at this point, and we're going to go all the way up to, and we're following the red, right? So we're on the red graph, which is the circle. So it's going to be from 0 all the way to 7 pi over 6. So we trace it. And since it's the circle, it's going to be the circle squared d theta. So that's the first part. That's going to give us from here all the way to here. And then we're going to do 1/2. And now we're going to start the green. So it's going to be 7 pi over 6. And we're going to trace that to 11 pi over 6. So we just want to go around the shaded region. And since now we're in green, we're going to do 3 plus 2 sine theta quantity squared d theta. And so, I don't know if you guys can see this, but there's a tiny little piece right here from 11 pi over 6. And yes, I could pull the 1/2 out if I wanted to. 11 pi over 6 back up to 2 pi. And that's going to give us, and again, that's part of the red, so it's going to be 2 squared d theta. And so that is a very long way of doing the problem. There's a slightly abbreviated version that we can do here, but again, all we did was trace it. So the other way we can do the problem is, and I'm not going to change the middle part, this green part here. So the green part is still going to be the same. But I want you guys to see that the red part, so actually let me just write this out for us. So this is another way of doing the problem. And this goes back to the previous video that we just did, is I could, if I wanted to, start here and trace all of the red. All of the red. So where I will end here at 7 pi over 6. Well, like we said before, if I want to start here, this is not 11 pi over 6. This is actually just negative pi over 6. So if I want to travel from here to here, I'm traveling in the negative direction, pi over 6. So I could actually rewrite this as negative pi over 6 to 7 pi over 6 of 2 squared d theta, and that would replace this and this. That would actually combine these two functions together. So hopefully that makes sense to you guys on what we're doing. And then, like I said, when you're doing common interior, you just trace the shaded region. So when you put this in your graphing calculator, you are going to get, hopefully this is correct, you're going to get 10.370 as a decimal answer. So I hope that makes sense to you guys, and we'll come back and I'll see you guys in the next video. Take care.